Hello everyone, I'm Shriyam, a CMI alumnus, and in this video we're going to look at this problem which came in CMI 2019. Now this is a very beautiful problem because even though it looks like an algebra question where you have 3 equations and 3 variables, but it's actually not. And the solution is really going to surprise you guys. So from the first equation we can say that if x square plus y square is equal to 3 square, then we can always construct a right angle triangle with side lengths x, y and 3. So let's start off by doing that. So suppose this is 3. We get our right angle triangle with side lengths x and y. Now if we look at the second equation, we can rearrange the second equation like this. This is nothing but y square minus 2yz times minus half plus z square equal to 4 square. Now this should remind you of the cosine rule. So from here you can say that there is a triangle with side lengths y, z and 4, and this angle in between theta is such that cos theta is minus half. So from here we can say that the value of theta is going to be nothing but 120 degrees, right? And if we similarly do it for the third equation, we can rearrange it to get x square minus twice of xz times minus root 3 by 2 plus z square equal to 5. So we get a triangle with side lengths x, z and 5, and the angle in between them is 150 degrees, right? So let's complete this figure, or let's redraw it again. So you'll end up with something that looks like this. So this is going to be 3, this is x, y, this is z, sorry, this is 4, this is z, and this is 5, right? Now why can I draw a figure like this? Because if you look carefully, the angle around this point is nothing but 360 degrees. So I can complete this figure. Now, one thing you should have noticed is at no point in this question were you asked to find the values of x, y and z respectively. All you had to do was find the final value of this expression. Now this is a very weird expression. We can't really relate it with any of the equations given to us. But since we use the cosine rule in this problem, it's only fair that we also think about the sine rule. So using the sine rule, I can say that the area of this first triangle is going to be half times xy, or just the standard formula for a right angle triangle. But in this triangle, the area of this triangle is going to be half times yz times root 3 by 2, right? Half the product of the sides times the sine of the angle in between them, right? And similarly for this triangle, the area is going to be half xz times half, because sine of 150 gives you half, right? Now if you add these 3 expressions, let's see what do we get. So you get half. If you take that common, you'll get xy plus yz times root 3 by 2 plus, this is going to give you xz by 2. Take this half outside again, you'll get 1 by 4 times twice xy plus yz times root 3 plus xz. And this is precisely the expression that's given to us. Now what is this total sum? This total sum is nothing but the area of the entire triangle, which is nothing but half times 3 times 4, right? So that gives you 6. So this is equal to 6. So the value of this expression should be 4 times 6. So the final answer is 24. Hope you like this problem because it had a very unique approach. It was an algebra question and we converted that to a geometry question. For more such fun problems, do stay tuned, and if you want more interesting problems, do let us know in the comments.